I just want to walk you through the critical parts of the normal distribution lab. So I'm going to do it using the dataset OAW 2309, the Olympia Airport weather data. And I'm going to work with two different variables, Tmax, which is not too far from normal, and PRCP, which is extremely right skewed. So just to remind you of what's in the data frame, we have these two variables, Tmax and PRCP. A lot of zeros in PRCP. So the first thing is to do a comparative density of the variable that you're looking at, and compare it with the standard normal distribution that has the same mean and same standard deviation. And I think this is really the better way to do it. In the textbook, in their lab, they use a histogram. And that kind of works, but actually, I think it's clearer if you're looking at the same kind of display for the normal distribution as for the actual data. So here we can see what's going on. Start over here on the far left, around 30 degrees or so. You can see that the normal distribution has more data than the data. Then starting here, you see more data in the data than in the standard normal distribution. And this is a little bit to the left of the mean, or left of the median. And then you have less data than you'd expect in this area. And then you have some crossover, some intertwining. If this were really good, you'd see intertwining all the way around. But the peculiarity, the deviations from normality really occurs in the middle. And you wouldn't be too far wrong if you were to try to use this as a normal distribution. And here's the other way that they wanted to look at it with this curve. And you can kind of see there's always, in these QQ plots, there's always a slightly funky area at both the bottom end and the top end. And you can kind of ignore that. And you can see that there's a deviation from a straight line which occurs in the middle. You can get the same plot in base R. And I kind of like the base R thing better because it gives you a reference line that you'd like to see the distribution just hug that reference line. Now, if we do the same things with PRCP, you can see the huge concentration of data at 0, whereas the normal distribution would be about here. Instead, you've got about here. And then there's a little bit less of data right to the right of the median. And then the two variables basically overlay each other. Both the normal distribution and the actual data kind of overlay each other out to 5 inches, where nothing really happens. And here's the second method, the QQ plot for this thing. And you can see that this is clearly not what you'd like to see for a normal distribution. And here's the same thing using the base R functionality. And this is the line that you'd want to hug if it were truly a normal distribution. Finally, we come to this comparison with, do a QQ plot, but compare it with multiple simulated versions. And here's the QQ plot of the simulated data. And if you look at, this is for PRCP, if you look at the actual data, this is what it should look, this is what it looks like, and this is what it should look like if it were a normal distribution. You can see right away when you compare these this plot with the other 8, that you've got something that's clearly not at all like what it should be for it to be a normal distribution. For Tmax, you can see here's the actual data's QQ plot, and here's the all the simulated data with a normal distribution with the same mean and the same standard deviation. And again, you can see slightly in this thing that you've got this something weird going on towards the middle. Okay? So again, let me go back to the beginning. And this, I think, the two densities, the standard normal density with the actual data density, I think this is the cleanest, clearest way to compare the data that you're looking at with a normal distribution.